Alright, you're welcome to the class of Math 232 again, elementary differential equations. We are looking at solutions of differential equations now. This time we're not solving a differential equation. We only want to check if this differential equation is having its solution. I mean, if this solution satisfies a differential equation. This is a differential equation, dy dx equals 3x squared. This is a differential equation. The differential equation here can simply be solved and you get the value of your y to be 3x cubed upon 3, which is the same as x cubed. But it's not always as simple as this. I mean, the solution of a differential equation is the same as the integral of that differential. But it's not always this simple. This is simple because it is only the independent variable we have a. Now let's assume I'm having dy dx is equal to 3x plus 4y. Bro, this is not that simple. You've got to use the linear ordinary differential equation method to solve this. So solving this now, we arrive at something y equals to something. That y equals something tells us that that thing is the solution of this equation. This one that we have here, y equals to x cubed, that is the final answer, is the solution to this differential equation. And that is how the case is. Now, let's look at the differential equation. Let's look at the differential equation and the two types we might have. If y is equal to I e raised to power ix, this is a complex number. Complex numbers will always have I. So I can say this thing is in set of a complex number, everything here. But x is a real number here. It is the imaginary part of this complex number ix. So this is another one, y equals to 3x squared plus 2. This is having I in it. This doesn't have any I. We call this a complex solution. We call this a real solution. Why is it complex? Because it has I. I is the imaginary unit of complex numbers. It is the symbol to represent complex number. I is the same as square root of minus 1. So instead of writing square root of minus 1, we're writing I. And this one doesn't have any imaginary unit. Hence, it is a real solution. Now, according to what we said, we will be solving a differential equation. We will be checking if a particular solution satisfies a differential equation. A very simple one first. I said the solution of a differential equation is the integral of that equation. So y dy dx is equal to 8x cubed minus 4x. This is a differential equation. The solution is very obvious because you can just do what? You just integrate this out, and that is 8x cubed plus 4x with respect to x. That is going to be your dy. I mean integrating both sides. I cross multiplied and integrated both sides. So the integration is here. Integral of dy is y. I mean simply writing y instead of doing integral again. And 8x to the fourth power upon 4 plus 4x to the second power upon 2. That is integration. You can go through that later. So 4 here, 2. 2 here, 1. 2 here, 2. And that is equal to 2x to the fourth power plus 2x to the second power. This is y. Y equals to this. Y equals this. So if this is the equation given to us now, and I want to check if this solution really satisfies this equation, it is obviously done. I can say dy dx is equal to 8, let's bring this here, let's use another way, minus 8x cubed, that's from plus, right, minus 4x equals 0. There is nothing here again. Now this is y. Check if this your solution works out. This is y, right? So what is dy dx? Dy dx is 2 times 4, 8, x raised to power 4 minus 1. That is integral, right? Differentiation, 3. plus 2 times 2, 4, x raised to power 2 minus 1, which is ordinary 1. Now, if you do this again, dy dx minus 8x cubed minus 4x equals 0. You can see that these and these are exactly the same thing. That means the value of y here satisfies the equation here. It is this simple, but it is not this simple. This is very straightforward because we're using x. Now let's get involved in something that is kind of linear. A linear differential equation of the first order and first degree plus 3y equals 2x. You can integrate this. We are going to be solving this with the normal method later. We'll get there. We're only checking right now. So you can integrate this. Now, we want to take this. Y is equal to a cosine 2x. Find or deduce that y equals to a cosine 2x is a solution of the differential equation d squared y upon dx squared plus 4y equals 0. You are asked to find. So, is a solution of this. Is this a first order or second order? Second order. Is it an ordinary? Yes. So, ODE. Now, this y equals to a cosine 2x is a solution of this equation. How do we confirm that? That is what we want to do in the next video. Thank you.